In today's class, student, I'll discuss illustration based on wave motion. Right. So stay tuned, everyone. We'll go through logic. Yes, everyone. For the heading, attention. Okay. So student, let's start the class. Okay. So now just wait for I can say at least 1 minute, 1 to 2 minutes, so that maximum student can get benefit of the class. Okay. Uh, so now student, I'm going to start your class here as usual. But I have a look at the question here. So student, this question is asked in J 2025. Student, this question asked in J 2025 main, not advanced. Yesterday, I guess last yesterday beta, I did a few questions based on advanced. So I'll take today all kinds of numerical advanced means also. So this is beta against questions number which is I'll not see entire questions because it's a time taken only. So it's what's the questions in the data here? This is JEE beta advance to sorry, it means my dear 2025. Okay, so Jai Sitama student. So what's questions here? Beta a sinusoidal wave of wavelength. Beta just I'm writing here in step one, my dear. That is given data of the questions. Student, that is given. So beta there is wavelength mentioned here. That is what, my dear? 7.5 centimeter, right? Okay. And travels a distance 1.2 meter long. Beta, I can see distance travel, student, that is 1.2 centimeter along x direction. Beta, question mentioned here. Along with Hare Krishna, my dear. So this is I can say Ara beta. I started just I can say last 2 minutes. You can see beta. Just 2 to 3 minutes. So just this is beta first question of today class. Beta this question came in, my dear, JEE Main 2025. But I'm not giving you entire data of the question, but I'm not writing. Just I'm giving you data. So, beta, what question says? A sinusoidal wave of wavelength 7.5 centimeter travels distance 1.2 centimeter along x direction in beta time is mentioned also. That is beta zero point 0.2 seconds. Uh, that is beta what? 0.2 seconds. Beta it's a 0.3 seconds there. It's a 0.3 second. Okay. The crust P at what? X is equal to 0 times 0 by the party and maximum displacement of the wave. Maximum displacement. Students mention the questions. Displacement maximum. That is what, my dear? 2 centimeter. Right. Which equations correctly represents this wave? Okay. Now, beta, I'm going to write here options. This is a data mentioned in the question, student, that is a wavelength, displacement maximum, time, and distance along x-axis. Uh, beta sine graph. Sine graph, it's simple. Beta, this is sinusoidal function here. You can take beta as the assumption. This is what by is equals to sine x, which is simple, my dear. Okay. So here is now I'm going to write here option first. So beta, what is option first here? Beta, that is mentioned in the questions. Y is equals to y is equals to, my dear, to this is what sine 0.8 3x minus 3.5 t in centimeter. Beta option number second, y is equals to 2. This is cos 0.13x minus beta ji 0.5 t. Again in centimeter only. Option C is student, y is equals to 2 cos 0.83x minus 3.35 t in centimeter. Last which are the options? Y is equals to 2. This is cos 3.35x minus 0.83 times beta centimeter only. Hare Krishna, yes, beta. How are you, my dear? You got delay to join the class? Okay, Arab. I don't know which Arab. Just now I wrote the beta. I can say in front of you only. So just give me some time here to think the questions because someone joined just now. Like yes, SS joined just now here. Just give me some time to assess. No, that is one information here which I wanted to write. Bacha. What's the question mentioned? At crust. At beta crust here. This is what particle is at x is equals to 0 and time is equals to beta. This is a very good information here. Student, this is a literally very good information to do these questions. At crust, point P is what? X is equals to 0. T is equals to 0. Okay. Now, beta, I'm going to solve these questions here. Okay, fine. Someone already answered the question, but I don't know your answer is correct or not correct, beta. Beta, literally, if all of you liking session here, at least show reaction here and like session, bacha, everyone. Yes. Now, beta, have a look questions here. Uh, bacha ji, what question says here? We'll go through this. Beta particle motion, I can say what? Particle at x is equals to 0, t0. So we can think first, what is the basically beta function from where start, right? So bacha party, first lambda is mentioned here in these questions. So beta, as you know everyone, you can find the velocity of wave. So this is, I can say step one for the questions. One already have taken here. This is step two, or you can say this is step one for solution part of the question beta. Okay, so you can use your what speed of particle. This is what beta you can write distance upon time. So we can write here. This is beta mentioned here 1.2 centimeter. 1.2 centimeter. Here beta you can see here. This is 1.2 centimeter. Time bacha how much mentioned here? This is 0.3 bacha. So you can write beta ji. This is 0.3 here. Concealer. So you can see speed of basically beta you can write 4 centimeter per second. Speed beta what you can write 4 centimeter per second. Okay. Amplitude beta, what mentioned in the question, sir? This is the displacement maximum. If you remember in the classroom, today also I repeated. What is the amplitude? This is what they mentioned here. Displacement maximum. It's nothing but in the questions here, indirect way, they mentioned this is what amplitude. So you can write Pachapati. Amplitude, which is equals to 2 centimeter, which is equal to 2 centimeter. Beta wave number you can find here, everyone. So what is wave number Pachapati? This is what you can say 2 pi by lambda. So this is 2 pi beta. And what's the wavelength here? Mentioned 7.5 centimeter. 7.5 it's a centimeter here. So KSR what will you get here? Just solve anyone further. So K which is 2 into 3.14 upon beta 7.5 which body. Anyone solve answer you which body? Okay. Okay, fine. Yes. Beta Arab actually I was busy with solving questionnaire, so I didn't see chat beta what you wrote. Correct, Arabita. Very good, Arabita. So finally, beta, I can solve here. You will get basically, beta, this is what 0.83. Okay, what will you get 0.83 here? Now, beta, I'm going to use here. I can see this is what step two for the solution of the part of the questions only. Bacha ji, here you can write here. because you know what is wave number, angular wave number बच्चा, omega by v. We wish to find omega here. So omega what you can see, v into k. So omega beta what you can write, v into k बच्चा. Correct, 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 correct. Yes beta. Very good बच्चा. So v बच्चा how much here? We already found. This is what, 4 into beta 8.3. Solve बच्चा party will get here. Omega is equals to 3.35. 3.35 beta approximately. Yes, yes, correct, correct. Arab, good, 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 good. Arab, good beta. Very good job. Very good job. Arab beta, yes, yes, if you're literally liking session here at this point, beta, just show your enthusiasm, bacha, like show reaction and like session, bacha party. Okay, till now I can see there are 6% and like only beta, two only 7% here. 3.35 bacha party. So beta, what mentioned? I can say crust. So beta, I can say in the beta, what's mentioned in the particle. The question here, x is equals to 0, time is equals to 0 bacha party. So simply you can write here. Y is equals to a cos of kx minus omega t. Because they mention here particle motion in what? Positive x-axis beta. Positive x-axis bacha party. So a bacha right here finally a is what? Amplitude which is 2 centimeter. Cos bacha party k into x here. K into x beta. K is what? Already we found 0.83x minus here omega t. Omega beta 3.35. 3.35 into t. Okay, so just match our options here. Which option is coming? Yes, correct, 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 correct. Correct here. See here. Canada, 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 Canada. Correct answer here. Canada is the correct answer. Good, bacha. Very good here. It's a little good question, bacha party. There is a little calculation, bacha. Very good here. Canada, Canada. Correct answer. Correct answer, bacha party. Okay, so this is there which we solve options number first only. Now, beta, find next question here. JE 2025 only, beta. Do beta everyone. Next question, beta. This is JE 2025 beta. Name only question here. Beta, what questions here? I can say displacement as a function of time t mentioned by body. X as a function of time t bacha mentioned here in these questions. Yes, beta. Yes, beta. Yes, 01. There is a class. There is a class beta ji. Okay. So x as the displacement as a function of time t which I mentioned in these questions here. This is 5 cos of 628 into t plus pi by 2 meter. Right, sir? Okay. The wavelength of the wave, beta, you have to find what's a party wavelength. If velocity is mentioned, 300 meter per second. 300 meter per second. Now what's a party? You can take what's a this is which I gave information mentioned in the question here. Time is late, so I'm not giving into the class too much like theory here. So pi beta what? 3.14. Okay. Beta option first here. Option first beta. This is 0.33 meter. Bombay beta ji 5 meter. Canada beta ji 0.5 meter. Delhi beta ji 3 meter. Okay. Okay, bacha. Answer the question here. Displacement expressed in terms of t bacha, that is mentioned in these questions. The wavelength of the wave when its velocity is 300 meter per second. So you need to find wavelength. You need to find wavelength. Okay. 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 Arab, Delhi. I don't know. Now I'm going to solve this question, bacha. Now, beta ji, I'm going to solve this question here. Okay. Fine. Okay. 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 Okay, beta. Arab. Wait here. What my solution? Beta for solution here. I can say it's a common question there. But just you can quickly search a party. This is the what you can say x as a function of time t. 5 cos of beta. This is not. 628 t plus pi by 2 meter. So what's I know, just equate at this equation. X as a function of t, a cos of omega t plus phi. Right. Simply beta I can see here from here. Omega is equals to 628. Just beta compare here. Let us suppose equation number one, equation number two beta. Just equate these two, my dear. So just equating here, you can say this is step one beta z. Now yeah, this is step two. This is what, my dear? Step two here. Okay, beta. Yes, yes. So you can write what's property for this condition omega. Omega is equals to 628. I hope beta all of you remember here. I can say what is the frequency? What is the frequency, bacha? Frequency beta what we can say? I hope you remember omega is equals to 2 pi f here. This one would omega is equals to 2 pi f bacha. So you can find frequency easily here. Omega upon 2 pi. Omega beta how much? 628 upon 2 bacha, and this is 3.14. Just beta double of this here. So finally beta just leave it here in terms of frequency only, right? We wish to find what? Wavelength. So step 3 beta, you can use here. V is equals to lambda f. V is equals to lambda f bacha body. So what about wavelength here? You can say V upon f. So V beta what mentioned in the question here? 300 meter per second. Beta f already be found. 628 into beta g. This is 2 into 3.14. Beta just replace two decimal places party. Then this is cancel here. So lambda is coming here 3 meter here. Are very good. Very good here. I'm very happy to see bacha your answer here. I can say Aravind SS. Very good bacha buddy. Options Delhi is the correct answer here. For our green. Sir, exactly. Oh, very good. You also joined. When you join beta? When you join beta, Sagar Maharaj? No, exactly three coming here. Not approx. Not approx. Yes, beta. Not approx here. It's exactly coming three, bacha. Very good, yeah. I'm very happy to see beta everyone here. I'm very happy to see bacha all of you in the live session, bacha. Okay, have it done. Next question here. Do everyone. Beta again here. This is JEE beta 2025 beta main question here. Now beta just I'm doing here in this class only main session bacha. I hope all of you are aware about today thumbnail here. Taste to knowledge. Right. So beta what's the questions here? Bacha again here. Here bacha party this is. I'm not giving entire question bacha party. The equation of a transverse wave traveling along string is. So beta this is what means by as a function of x comma t. By as a function of x comma t bacha. This is 4.0 beta g. This is sine of 20 into 10 to the power minus 3x plus beta 600 t. 600 t bacha. This is a question here. Where x is in beta mm and time is in second. Velocity of wave you have to find. Find velocity of wave. I'm giving option bacha party. Everyone. Beta this is plus 30 meter per second. Beta Bombay minus 30 meter per second. Canada bacha 60 meter per second. And Delhi you can take minus 60 meter per second. Present ISR. Oh, ISR. I'm looking first time where you. Oh, I'm looking first time where in the live session bus party. I never seen to you here. हाँ बच्चा पार्टी, टेल मी आंसर यार. ओके, अरब, बॉम्बे, अरब स्टेट बॉम्बे. ओके, any more candidate? If all of you literally liking, yes, sir, I'll see the video. Ah, it's highly required, beta Sagar. I said you few one year. Uh, yes, I said you few one year because I don't have the contact number of everyone. I said, okay, Bombay. Okay, Bombay. Yeah, if literally are all of you liking season of this point here, at if you are literally getting some knowledge, so yeah, at least likes video everyone here. So your reactions everyone. Okay, fine. Okay, Bombay, Bombay. Okay, yes, yes, very good. Very good, yeah. I'm very happy to see Bacha Pati everyone. Maybe your answer also correct here. I can say Arab responded me, and I can say ISR. No, there is no response. Okay, ISR just present only. Okay, ISR beta. ISR. Pay attention, my dear. Okay, so here, as I said in the classroom, Bacha Pati, velocity of wave. We can find here simply, Bacha, coefficient of t upon beta g. This is coefficient of x. So beta, what is coefficient of t by party? This is 600 here. And beta, this is what? You can see beta 2 into 10 to the power minus 3 mod entire here. Will goes up. So you can write beta 6 into 10 to the power 5 upon which party. This is what? You can say 2 here. 2 3 the 6. We can write what? 3 into 10 to the power 5 right now. Okay. So 3 into 10 to the power 5 and coefficient of t. It's a 20 here. It's a 20 bacha party. It's a 20. So you can say basically 1 decreases. So this is what? Beta, I have x in mm here. X in mm. Uh, this is the wrong solution here. So beta, you can see this is one cancel here. 30 into 10 to the power 3. 3 into what? 10 to the power 4. So 3 into 10 to the power 4. What you are getting? This is what? In mm. In mm. So what's 20, correct, Arbiter, 20 only here. So answer it about will get this is what? 30 meter per second. But you know, what is the direction of wave? What is the direction of wave, bacha? Negative x-axis here. So answer you can support here because option available. Otherwise, we can take a positive. So Bombay correct answer. Very good, yeah. I'm very happy to see, bacha. Yes, yes, yes. I'm very happy to see here everyone. Literally, all of you doing very good job. Literally, bacha party, all of you doing very good job here. Okay, fine. Just move it on next question here. Yes, beta. Move on next question here, everyone. Correct. Sagar, I got your answer very late here. You responded too much late. Too much late here. But next question here. 2023 बच्चा है. JEE beta जी 2023. Main question I'm just solving here. Main question बच्चा party. So beta what question says? Beta by as a function of x comma t. By as a function of x comma t. Okay. So this is what my dear? 0.05 sine here. This is 8x minus 4t in meter. Find velocity of wave. Find beta what? Velocity of wave here. So this is options one with party 4 meter per second. Uh, Bombay beta 8 meter per second. Canada बच्चा 0.5 meter per second. Delhi forever green here. This is beta z 2 meter per second. Yes, beta. Okay, Canada. I don't know, beta. Okay, Canada. Okay, Canada. Okay, okay. Any more candy? Okay, Canada. Okay, fine. SS and R are look like very active in today class. Canada. Okay, Sagar, three people. What about ISR here? ISR not available, maybe. I'm not getting any reply from ISR here. ISR. Okay. But I can see, bacha. Come, everyone further here. Correct, correct, correct. I'll see, bacha. Beta, velocity of wave, beta. We remember everyone. What we can see, bacha? This is coefficient of T. Upon beta, this is coefficient of X here. So coefficient of T, bacha, what we can say? 4. 4 by 8 here. Minus, no need to worry. This is what we can say? Basically 1 by 2.5. Oh, just remember it, which how they are asking question here. How is it? Okay, zero point 0.5. Canada. Oh, very good. Very good here. I'm very happy to see everyone here. Literally, which I'm very happy to see all of you here. What we can see, zero point 0.5 meter per second. Zero point 0.5 meter per second. Okay, bacha. Next question here. Do everyone. Hmm. J beta 2023. J bacha ji 2023. Okay. So now bacha, what's the questions? Here I'll do my dear. Which of the following? Here are just write down everyone entire questions here. It's not a very big questions. This is J2021. J beta G 2021. Which of the which of the following equation of which of the following equation represents represents a traveling wave? Which of the following equations represents a traveling wave beta? Okay. Now, our students, I'll write options. Answer everyone write. Give me from here only. Sir, can you move? Okay. Yes, 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 beta. Is it fine? I hope. Is it fine with Chapati? Sagar, beta? Is it fine? Is it fine, Sagar, beta? Hmm. Okay. Option first, beta ji. So this is by is equals to a to the power x multiple beta cos of omega t minus theta. Y is equals to a sine 15x minus 2t. Y is equals to a sine x cos of omega t. Last बचा जी y is equals to a e to the power beta minus x square vt plus theta. Which of the following equation represents traveling wave? Which of the following equation represents traveling wave? Anyone answer me from all of you? Oh, oh, okay, okay, oh, fine. Arab, Arab, you look like very active here. You look like very much active. Okay, okay, SS. Very good. Mhm. Okay, Sagar. Everyone answer here. Correct only, beta. Correct only, yeah. Correct. I think there is no such logic I have to explain, bacha. This is straightforward, yeah. Equation of what you can say what for traveling wave. Because this is what you can see straightforward here. What equation of traveling wave. I hope all of you done. All of you done, bacha party. I hope all of you done, yes. Okay. So which I can say this is the questionnaire which I gave you everyone. Bacha, this is one more last questionnaire for this pattern of the things. So this question, students, J2003, yeah, J2003. But here you have to find speed of the wave motion. Find student speed of the beta J. Find speed of the wave motion. Simple, bachcha. Find beta what speed of the wave motion here. Okay. In meter per second, bachcha. Keep in mind, you have to answer in terms of meter per second. Now, beta, I'm writing equations here. This is y is equals to 10 to the power minus 4 students. This is what sine 600t minus 2x plus 5 by 3. Right. So now, student, this is option for this question here. 300, 600, 1200, and 200. Yes. Answer in Vacha party. Anyone from all of you? Okay. Arab, A option. Arabli Hills. Okay. Arabli Hills. Okay. Arabli Hills, America. Okay. Okay. Apple. Oh, very good. Very good. Yeah, Apple. Correct, 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 correct. I have to solve this party. I can solve it. Wait. Very good. Yeah, I'm very happy to see beta, all of you. I'm very happy to see beta, all of you. So, velocity of behavior. I hope all of you remember. Beta, what we can say? Coefficient of t upon beta g, coefficient of x here. So coefficient of t beta how much? 600 here. Oh, correct here. Minus. So this is what made here? 300 meter. Okay. Atlas joy everywhere. Okay. Very good SS. Okay. Now beta ji. Next question, sir. Next question was about it. So this is a question here. I can say integer type. Right. There is no option at all, beta. Still, there is no option at all here. So this is beta. I can say problem based on integer type here. Right. Beta, you can say this questions ask beta J2023. Okay. So what's beta? Y as a function of x comma t. Find velocity. Still y as a function of x comma t beta. You have to find velocity here. Right. So this is students pi sine 60 plus 0.003x. Find velocity. 5 sine 60 beta plus 0.03x here. Find velocity of wave. Find velocity of wave. It's integer type. There is no option at all. It's integer type, there is no option at all. Hello. Hello. Yes. So this is the option. Anyone? Okay. Okay. I got answer. Yes, beta. Okay. Okay. Okay, fine. So simple. Okay. Ara. Yes, yes. Sagar. Okay. So beta had my dear solution everyone. So what beta I can see velocity of wave here. I hope all of you remember coefficient of t, coefficient of t upon beta. What you can say coefficient of x. So this is the let's say, can write 6 upon what 0.003. Just replace here. There are three decimal. This is 2000. Sir, can you derive velocity? Now. Yes. Sir, x and y are in centimeter. Beta, in the questions, you can take beta, don't worry. You can take this one, all are in SI unit. You can take beta in consideration here. This is what all are in SI unit. Okay. Now, so beta, I'm going to just, I can say stop here this practice session because of, I can say, uh, what's in India? SS wanted theory, means few theory. I also wanted to teach, right? So now, beta, many things I'll do more practice question in tomorrow class here. Right. So now it's I'm going to start here as usual topic. So attention everyone. Yes, beta. It's literally good here and happy to see everyone in the live session. Do more. Beta, I'll do more tomorrow in classroom. Beta. Little theory, beta. We can also understand. Okay. बच्चा जी, have a look, beta. So this is what you can see. Speed of beta. This is speed of wave on a string. This is what mediate speed of wave on string. Speed of wave on string. Right. Okay. So it doesn't here. I can say, or I can also say, you can also say, but this is what standing wave. You can also say, but this is what basically beta. I can say velocity of standing wave. Beta both are even same. You can take it as a consideration. Let us suppose in your hand. What? So this is what formation of pulses takes place in the string. So string beta, string length, mass we can consider. Uh, this is what mediate mu kilogram per meter. What mediate mu kilogram per meter. Okay. Now mu kilogram per meter, right? Okay. Let us suppose beta. This is what direction of velocity of wave. This is what direction velocity of wave. Beta, we concentrate here on the idea. I'll make I can say a video of this zone part. Let's say this is zone 3x. This is what zone 3x. Okay. So yeah, we listen here. Pay attention here, everyone here only. The class, on the class. Pay attention on the class, everyone. Look at here only. So this is what I'm going to make it. I can say a video of this zone part only. Right. So this is what is I hope all of you remember. Tension always acting along the string. Tension always acting idea what along the string. So let us say this is the intersection point. right? Uh, but there is little points here which you can keep in mind, everyone, right? So with this angle, let us suppose I'm considering theta. So we can see this is what remains theta. So here is you can see if this is theta here, so this angle is what remains theta. This is what remains 90 minus theta. So this angle is what remains theta. Sir, can you explain once again? Uh, okay, then I'm explaining again. Then pay attention, listen carefully. But what I'm telling you, let us suppose students, as I'm explaining, don't be more smart. This is string, right? And students, sir, please increase your voice. Okay. Is it fine? Is it fine with now? SS, is it fine now? SS, is it fine now? Hmm. Okay, fine. So student, just listen carefully here. What I'm telling you, you can understand. So we can. Hmm. Okay, fine. Hello. Is it fine now? Is it fine now? SS. SS, is it fine now? SS, is it fine now? Just revert me. Reply me. SS. Okay, fine. Okay. Now beta. So this is consistency. Beta, just listen here. Alright. Beta, this is string here. Now I'm considering first already formed, right, in the string. So beta, now I'm going to show this LVD. Just zoom 3x of this part. So this is beta what? Theta. This is what remains theta. So again you can say beta. This angle is what? Also theta. This is 90 minus theta. So this is what my dear? This is what my dear? You can say remains theta. You can say remains theta. Okay, fine. Now let's see. This is tension T. This is tension T. You know, tension corresponds to vector. Tension belongs to quantity vector. So you can take component. So this is what we did. You can write T cos theta. And this is what my student? T sin theta. Right. Then let's say this is released here. So we can say this is T cos theta. This is a large size vector. Okay. This is T cos theta. And this is what we can say T sin theta. Now I can say easily, sir, this T cos theta, hmm, T cos theta, these two are cancelling each other. These two are cancelling each other. So we can say that this is basically what? 2T sin theta. But I have one more interesting point. I hope all of you remember. Just now I finished few days long back. If any particle which is moving on a circular path, then what we can say centrifugal force always acting away from the center. So we are doing operation for a small element. So what is centrifugal force? You can take in consideration MVS per by R, but L is not, it's a dm because we are doing operation for small element. So dm v square by what? R. R with I think this is the radius of R. R is what? The radius of R. Now you can see the net force in horizontal which is equal to 0. So we can write it for vertical. For vertical. What it says? For vertical here you can write 2 t sin theta, which is equals to dm v square by r. Simple beta, you can easily understand here. Total upward force is equals to what? Total downward force. Okay. Bacha ji, we have to first find out what is value of dm. Right. Let us say equation number 1. So, but in case, what we have to take? Lambda. What we have to take? Lambda. So we used to find here, I can say mu. Mu, what you can write? Mu, you can write kilogram per meter. So we used to find, I can see this is. and beta kilo mass. So mass you can write what? Mu. And what is arc length? What is entire arc length beta? This is what arc and r beta. This is what 2 theta. So we can say arc length is what? 2 r theta. So finally beta, we got value of dm. This value of dm I can feed over there in equation number 1. And beta, one more consideration that take in your mind. Because this theta is what? Very small, very big. It's small. So if, I hope all of you remember, if theta is small, then beta what we can say? Sine theta goes to theta. Sine theta goes to theta. So now beta, I'm going to fit this value of dm in equations 1. And then sine theta goes to theta. So what you can say? 2 t theta, which is equal to dm. Dm is what? Mu 2 r theta upon r into beta b square. Now it is a simplification, all of you. This theta, converge. These are converge. These two converge. So t beta, what will get here? T is equal to what? You can write v square into mu. So what is v r? What we can say? This is t by mu. So now forever keep in your mind this formula. V is equal to t by mu. For what? I can say speed of wave on string. Speed of wave on string whatsoever. I hope all of you understand that how it came. V is equal to, in fact, today already we used this formula. V is equal to root of t by mu. V is equals to beta. This is root of t by mu. Okay, theta copaz. Yes, correct. Okay, note down here, everyone with me. Note down everyone with me on here. It's highly required. No. It's my pleasure, bacha, to help you, bacha. Stay placed. Stay tuned to this point here. That is highly required. That's what I'm feeling now. Here you will get everything according to your expectation. Because I'm taking classes, I'm working here because of students, right? For your betterment. So definitely better. You will improve your knowledge. Keep following BK sir. That is a hard work. Students, should I start next topic? Students, should I start next topic? Everyone, just respond me fast. Okay. Are you writing? All of you, are you writing, Bacha? Which what? Root of t by mu. Okay. RR, SS, Sagar, respond me here. Sir, what will do next? Problem based on this. Problem based on this. Okay. RM, telling wait. RM telling wait. Okay. RM, should I start? Next topic. RM, respond me fast. I hope you finished. RM, I hope you finished. Yes, okay, fine. Have a good one. Go next question. तो बच्चा जी नेक्स्ट क्वेश्चन बन गया बेटा फाइन क्वेश्चंस यार नोट डाउन फाइन फॉलोइंग बेटा क्वेश्चंस नोट डाउन ऑल ऑफ यू बच्चा फाइन फॉलोइंग फाइन velocity following speed of wave on a string and time beta first you have to find beta speed of wave on a string and second beta you have to find time diagram I'm going to draw it yes beta ji so let us say this is the kind of arrangement okay now this is the release beta this is pulley one end of the string, I can say string, this is fixed over here. Now there is one more block there. Mass of the block you can take. This is the 20 kilogram. This is what my dear 20 kilogram. Okay. Uh, mass of string, you can take in constitution strings, mu is equals to 3 gram per meter. Yes, answer me, my dear. Speed of wave on string and time and time. But this thing also mentions to this length here, entire length upper part of the string. That is, you can take it at 10 meter. That is, you can take what? This is what basically 10 meter. Okay, R of the 1 minute. Okay, you can take your time. R of, you can take your time 1 minute. Don't worry. Hmm. Okay, so that's all today. So that's all. Mass of block 20 kilogram. Already I mentioned. See, 20 kilogram. Mass of block is 20 kilogram. I said it's 20 kilograms. Mass of block, which is equals to 20 kilogram. Okay, fine. Now, beta, I'm going to solve these questions. Listen to me carefully, everyone. Solve this question. Okay, now, equity versa party. Equity versa easily this question. What is the maximum tension? So you have to also spare speed of pulse. You have to find the speed of pulse and time. Beta, what is maximum tensions? I can say string time. Oh yeah, that is what 200 meter. So T beta, you can say this is what 200 meter. T beta, what you can say this is what basically two. Okay, Sagar 14. Wait, beta Sagar 200 Newton. Yeah. So speed of pulse. Just speed of pulse. You can take your this is pulse. You're sending from here. So speed of pulse. Nothing but what we can see T by mu. T beta already mentioned 200. Yeah. Mu beta what we can see 10 grams. So 10 into what? 10 to the power minus 3. Understood? Okay. So you can see this is 1. I can see cancel with 20 to what? 10 to the power 3 beta goes up here. So you can see 2 into what? 10 to the power 4. So root 2 into 100. 1.41. 1.41 into 100 here. So you can see 141 meter per second. 141 meter per second here. This is the answer of the question here. No, Arab. 14 is the wrong answer. 14, Sagar Beta, wrong answer. Sagar Beta, 14 meter per second is the wrong answer here. Your answer which is your answer which is 141 meter per second. 141. So take G 9.8. Okay, fine, fine. Maybe there is a variation. But I think then there are then this is not easy to say. 14. It's a very huge differences. Check your calculation once, beta, Sagar. Okay, beta now yeah, fast one bacha. Now yeah, I'm going to show bacha. This is what I can see part number two. What's the part number two? You have to find time here. So what is the time? Time is what beta we can say. Distance upon speed. Distance upon speed. Yes. What's the distance that market? Distance what you can say. This is G bacha, and we got 141. So this is what in second year. Answer of this question. 10 upon what? 141. Okay. I hope got it everyone. I hope got it everyone. Fine. Very good. Yeah. Now, beta, one more question I'll do here. Then I'll do beta start of the last of the questions, right? Because it's a request by student. So that I did. Otherwise, beta, I have many questions here based on I can say juggling way. We have to do practice. Yes, beta. Now I can see beta both identical. Are 141 correct answer only. beta, both strings are identical. Students, this is the kind. Just look at it, given here on the. So beta, what says both strings are identical. Both strings, beta, what it is identical, right? Okay. So this is beta is here on rod. This is rod. Okay. So beta, here you can find. Let us suppose T1. This is what T2. Beta, one mass here. One mass you can take, which is mass of the block. You can take 10 kilogram. You can take 10 kilogram. Hmm. No, correct only, Ara. See, I wrote only 10 by 141. I wrote 10 by 141 beta. How wrong? It's correct only. Hmm. Ara beta. But I can take what's what this is what. This mass from I can with respect to this system. Bachaji 25 centimeter. And I can say with respect to this system. This is what? 75 centimeter. Beta. Find T1, T2 and V1, V2. Find what's the party? T1, V1, T2, V2. Find what's the party? T1, V1, T2, V2. Find what's the party? T1, V1, T2, V2. Okay. Do what's everyone. Okay. Now, beta, I'm going to solve this question there. Solution everyone. Solution everyone here. This questions. Beta, what you can say initially here? T1 plus T2 is equals to what? Mg. You can take beta mass of rod also. This is in kilogram. Okay, I'm doing beta. Listen, listen, listen. Beta, let's make a video beta. A video of this rod. Right. Students FBD of rod. So this is I can say rod here. You can take it. So this point is what? Acting tension stable. This is what T2. So T1 plus T2, system remains in equilibrium. So you can say it as T1 plus T2 is what? Mg. T1 plus T2 is what? M1 beta mass of the rod. M2 beta I'm considering mass of the rod into G. So you can write here T1 plus T2 is equals to beta 200 Newton. Let us see equations number 1. T1 plus T2. What was the party? T1 plus T2, which is equals to 200 Newton. Right. Okay. Then beta, we can apply a torque concept. So here I'm taking torque with, let us suppose this point I'm calling O right here. So here beta, this is step 1 right here. Everyone, this is step 2. So here is when I'm taking torque with respect to point O. With respect to point O. So torque itself beta, we can say for T1, 0. Torque due to beta only possible, I can say for this mass and rod and what I can say T2 only. Right. So beta B3 because you are taking torque from here. So what is torque? Force into perpendicular distance. Force into what? Perpendicular distance here in upper directions. So this is what my dear. Because it in kilogram into beta. What is the force? 0.225 torque due to 10 kilogram. Torque due to 10 kilogram plus beta. Mg force here also mg force से बचा again inward हो गया. So beta mg force what you can say? Tail. Mg force what? Always acting center of mass of the body. You can write here. Tail into what बचा? Because everywhere the force there. So you can also say this is 100 mg. Right beta 100 here. Into beta what we can say? Uh, beta this is mg force. Again here 100 newton into beta 0.5. This is beta torque. Again I'm repeating. This is the torque beta due to mass of block m. This is torque beta due to torque. Then let's say what you can say is equals to what's this is what G2 into what's entire length 1 meter here. So now parameter will get G2 from here. So beta 100 into this is what you can say what's 25 plus beta this is what you can say 50 is equals to T2. So T2 beta how much will you get? This is what 75 meter. Once you will get T2 you can easily find T1 from equation number 1. Let us say equation number 2 what's because T1 plus T2 is what 200 here. T2 already got 75. So T1 is what? T1 you can write 125 Newton. T1 you can write what? 125 Newton. Right. T1 beta got. T2 got here. Simply we can find here V1 V2. Simply we can find here V1 V2 bachcha. Okay. Then you can ask what is the mass of the steam bachcha. You can take here. This is 10 gram per meter. So now student, I'm going to just solve it for that part on next paper. I want to turn here anyone. If anyone writing, oh, okay, already Arab already answers T1 125, T2 75. Okay, Arab got it. Good. Now it's easy. So now we wish to also find what? Good bit Arab. You are very much active there in the classroom. You are not in like this kind of introduction. And so this is what human beta what we can see. This is what T1 upon V1 here. T1 here just now already solved. How much here Arab? 125. So this is 125. 10 gram here. So 10 into what? 10 to the power minus 3. It goes up here. So V1 what you can say? 125 into 1000. Cancel here. So this is V1 beta will get 10 root 125. Beta further we can solve here this one here. 5 times of 5. You can take it out here. So V1 you can say what? 50 root 5 meter per second. Beta V2 what we can see? This is G2 upon V2. V1, V2 remains same here. V1, V2 beta remains same. This is what 10 gram per meter. 10 gram per meter here. So V2 beta, you can see G2 here. What's the G2 beta? 75 upon beta 10 into 10 to the power minus 3. So V2 you can write beta 75 into what? 1000 upon 10 here. This beta, though 7.5 we can take. So this is 7500 meter here. So you can see 10 and 5 5 5 root 3. So this is what you can see 5 coming out. So this is what you can say 50 root 3 meter per second. This answer here. Correct. Okay. So now beta, I'm going to stop here. This I can say further. I'll not continue this much here. Right. Let's see. Uh, beta here. I'm going to solve a question based on this only. We do have few questions from advance. Yes. Uh, I'm not reading here. It is the reply from just except Arab. I don't know what about SS and Sagar. SS and Sagar beta. Where gone both of you? SS and Sagar. Where gone both of you? Hmm. SS and Sagar. Where gone both of you? Okay. Hmm. Be ready again for answer here. Okay. बेटा note down question everyone here. Everyone note down questions here. Sir, when will you end? 9 o'clock, beta. Just after 5 to 10 minutes. After 5 to 10 minutes, yeah. Arab sir will do PYQs now. One question as you advance. One question, beta. This is the last question, beta, for today class. Arab today are not replying too much, yeah. Sir, we are there. Okay. SS, you are also not replying too much, beta. J, beta advance. This is the last question for today class, yeah. J advance to 008. It's not but good. I can say that question here. I like entire data. Note down with me, everyone. Transverse sinusoidal wave. Uh, beta transverse transverse sinusoidal. हाँ बेटा जी transverse sinusoidal wave moves moves along or string hmm, hmm. Yes बेटा forgot यार hmm. Along the string in the positive x direction at a speed 10 centimeter per second. The wavelength the wavelength the wavelength of the wave is zero point 0.5 meter and its amplitude and its amplitude 10 centimeter at a particular at a particular time t at a particular time t the snapshot the snapshot of the wave is shown in figure. Yes, beta. Full stop. The velocity velocity of point P velocity of point P when when its displacement is 5 centimeter. Displacement is 5 centimeter is sir give 5 minutes. Okay, I'll give it option first root 3 pi upon 50 j cap meter per second. Bombay air minus root 3 pi upon 50 j मीटर पर सेकेंड कनाडा बेटा √3 पाई upon 50 लास्ट बेटा जी माइनस √3 पाई upon 50 आई कैप मीटर पर सेकेंड राइट बेटा ग्राफ हम just drawing this today which is already mentioned in the questions. This is x and y. Okay, this is the point here. P. I will question once a transverse sinusoidal wave moves along the C in the positive x directions at this speed. So this is the velocity of wave bacha. At this speed, this is 10 centimeter per second. The wavelength of the wave is 0.5 meter. Okay, its amplitude is 10 centimeter. Amplitude 10 centimeter. I hope all of you remember here. This is nothing but its amplitude. Today also I repeated it, or maybe yesterday. Its amplitude, that is 10 centimeter at a particular time t. Snapshot is mentioned. We have to find velocity of particle over here. So velocity of particle here, what we can say? Minus times velocity of wave into beta what? Into beta what? Slope here. Right now. So you can do here these questions. Not very much tough. It's a little thinkful questions. Yes. Just do these questions carefully. Okay. I hope done everyone. Fine. Yeah. First tell me, what is the direction of velocity? Because in this question they asked two things. In these questions they asked two things here. In this question they asked two things, Bacha Party. Okay. Anyone from all of you? Can you answer me? Anyone from all of you? Okay. Wait. Hmm. Okay. Fine. Hmm. Do. 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 Yes. Got it. Do fast. Do fast. Okay. Should I solve a student? Sagar, why not responding, beta? Hmm. Yes, yes. Both of you here look like silence today. Hmm. But today class is not much tough. I did many questions here for same concept repeated. Okay. Now yeah, I'm going to solve this question here. Time is I'm taking too much enough. Okay, fine. Okay, A option, Aravalli Hills. Okay, let us see. Bacha, first tell me, what is the direction of velocity of particle? Everyone answer me first this question. Everyone answer me this thing. What is the velocity of particle direction at point P? Y-axis what? Plus or minus? Sagar correct beta. Sagar correct beta y-axis, but plus or minus? America. Okay. Answer me here. What is the plus? Correct, 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 beta Sagar. So first you can tell bacha कि particle P here. This is directional velocity. So no, what we can segregate an answer. We are pretty confirmed C and D not possible at all. C and D not possible at all. Either answer A and B is correct. That is the point. But, Sagar, if you remember your today class, as I derived velocity of particle, this is what? Omega root of a square minus by a square. A square minus by a square. Omega beta what we can see 2 pi f. So velocity of particle you can write omega is what? 2 pi f here. 2 pi f beta frequency here. Amplitude a square minus by a square. A beta mentioned here. How much? Amplitude bacha 10 centimeter here. And displacement is how much? Beta I can see wavelength 0.5 meter here. There is displacement also mentioned here. Something beta. This is a particular displacement here, 5 centimeter. Right. Everything mentioned in the question itself here. So beta, how can you find your frequency? This is what V upon lambda. Frequency beta, what we can say here? V upon lambda. Right. So we mentioned here. This is what? Speed of wave. 10 centimeter per second. And wavelength is what? 0.5 here. Right. So beta, you can say beta velocity of particle is equals to 2 pi a beta. And frequency beta, what you can say? This is what? V by lambda. Frequency beta, what you can say? V by lambda. Very good, Sagar beta. So beta, this is what you can say by chapati V. V beta, how much? Zero point 0.1 here. Zero point 0.1 upon what beta? 0.5 meter already mentioned here. So no need for conversion. A bacha 0.1 here. Beta 0.1 bacha chapati whole square. Beta minus here. By beta, how much? By beta? This is here. 0.05. Yes, bacha chapati. Further solve here, answer will get something which positive only here. That is also you can solve. No need to solve further here in these questions. Aravali Hills. Yes. Correct answer here. Correct here. Options A is correct only. Correct. Beta. Options A is correct here. Very happy to see bacha everyone here. God bless you all. Now, students, I'm going to stop here. I can see this live session. I have to start next class. Beta. God bless you all. Very good. I'm very happy to share. Answer correct, bacha. Good.